Hi team, thanks for showing up for your learning with this video. Some of you have asked for a couple topics, finding domain and range with technology and selecting a form to find a quadratic feature. Would you like to see a few more examples? So I'll show you some examples. Here we go, find the domain and range with technology. If we want to know what the domain and range of this funny looking function is, we could plug it into Desmos. So it's the square root of x minus 1 minus 4. So let's do that. Let's get a fresh Desmos. And notice I always have a Desmos tab open. I'm using Desmos all the time. You want to use Desmos all the time too, okay? Because it will build your abilities. So I've got the square root in there, square root of x minus 1, and then outside the square root, minus 4. Make sure it looks just like what you're seeing in Delta Math, because if you plug that in wrong, like where the square root sign maybe ends like there instead of there, then it won't be correct, okay? And then we can visualize what this looks like by looking at the visualization. So we see here, we've been asked, what have we been asked for? Domain or range? The range of this function. Okay, cool. So I see that it starts down here at negative 4 and it's growing. Oh, look, there was the clue. The negative 4 is the start of the range. And then it's growing from there. But it's growing really slowly. Let's see what happens if we look at if we see if we can get really large values of y. If we look at larger values for x, let's see. Oh yeah, y can go really big here, you see? So y is going off to infinity. So that would tell us that the range started at minus 4, and it was just, that's less than or equal to all y values. And that's done. Submit the answer. Hooray! So that's what we saw on the graph. Okay, let's look at some more examples. New problem. All right, f of x is equal to 1/2 to the x. And we want to find the range. Okay, well, it's going to be y is greater than 0. And I'll show you why. I'll show you. Let's get a fresh Desmos, everyone. And then we're going to type in y is equal to 1 over 2 and the bracket outside there. Then raise it to the power x. Okay, so here we go. With negative values of x, seems like this gets very, very large. So y can clearly go to infinity. But does y ever get below that x-axis? No, it's not. If I zoom in over here, there will always be a little gap. It will approach but never touch. See how there's that little gap there? It's 0.0011. And no matter how far I go or how big I let x get, y will still be non-zero. It's a special thing about these exponential functions. So try that. Y is greater than 0. Done. Submit answer. Yes. Yay, hooray. Graph the function using technology. So we did that. And then minimum very close to y. Closer and closer, but does not touch. Maximum y value is infinity. Hooray. Okay. New one. Let's take a look at some more. Okay. Use graphing technology to find the range of this one. Well, all I need to do is find the vertex here. So the vertex is going to be over at negative 3. And if I input negative 3, how did I know that? How would I know where the vertex is just by looking at it? Negative b over 2a. The 6 is b, so negative 6 over 2 gives me the x coordinate of the vertex, which is negative 3. Negative 3 input into this function is going to give me 9 minus 18 plus 1. So that's going to give me negative 8. So y is greater than, y is, yes, greater than or equal to negative 8. Submit that answer. Hooray. Okay. If we had graphed it in Desmos, it would have told me that the vertex was over there at minus 3, minus 8. But I can find that by using one of our tricks for finding the vertex. Okay, so the minimum y value is minus 8, and the maximum, it goes up forever. So the range, which is possible y values, is minus 8 and greater. So that's how we write those. So that's that topic. Let's take a look at selecting the form to find a quadratic feature. Okay. A quadratic function's hidden from view, and we want to find all the intervals where it's negative. Okay, so I'm going to show you a quick visualization in a fresh Desmos of what they're talking about. Let's say I have a quadratic function that's x squared minus 5x plus 2. Okay, and I want to know when is this quadratic less than 0. Well, it's less than 0 only between the roots. See how the roots are the point where it transitions from positive values up here into negative values down there? So if I knew the roots, that would be really useful for finding out more about this quadratic. Let's take a look. So let's give me a form that will show me the roots very easily. Factored form. Dun, 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 dun. Oh, that's interesting. So minus x minus 5 to x minus 1. This is a parabola. It opens upwards. So I know that its vertex is going to be a minimum. And it has roots at x is equal to 5 and x is equal to 1. So let's let's dump this into Desmos and see what it shows us. Okay, it's going to look very similar to this one. Oh, what did I tell you? So has these roots. Between those roots, the function has a negative value. You see, the value of the function is its y value, and it's negative, although its minimum is down there at minus 12. And then, so anywhere between the roots, it's going to have a negative value. So let's input that. We know that between 1 to wait, choose, yeah, okay. We want to find all the intervals where f of x is negative. So 1 is less than x, which is less than 5. I didn't say less than or equal to because equal to would give me times where the value of the function is 0, and 0 is not properly negative. Let's see if it likes this answer. Hooray! Okay, so there we go. The function is negative for 1 is less than x is less than 5. There. The function is negative when the y values are below the x-axis. So that's how I would choose a form in that case. Let's look at some more examples. New problem. Okay, it's hidden from view. We must find the x-intercepts and write them in the form xy. So if I'm looking for x-intercepts, again, go back to a visualization, I want factored form because factored form gives me the roots, and x-intercept is another word for roots. There are 2 of them, 2 x-intercepts in this case, and they are 3 comma 0 and negative 1 comma 0. Okay, so these are the 2 roots. They're the 2 points where this quadratic touches the x-axis, and I get them from the factors. If x is 3, then the value of the function is 0 because this term is 0. And if x is negative 1, then this term is 0, so the value of the function is 0. So that's how I would choose. That's why I would choose factored form in that case. Let's look at more examples, and I'll get one where I need vertex form or standard form. You must find it where f of x is negative. There I'd use factored form. It's still going to be factored form. Here, where f of x, there we go. You must find all intervals where f of x is decreasing. All right, well, let's look at a parabola again. Okay, this parabola, notice as x gets bigger, y is getting smaller all the way through there until something strange happens around the vertex. X is getting bigger and suddenly y is getting bigger again. So these areas from the vertex on are increasing. They have positive slope. These areas moving towards the vertex have a negative slope. They're decreasing. So I can see that it changes from decreasing here to increasing when I pass the vertex. So I would like to know where the vertex of that function is so that I could tell them where it is. Okay, so I want to know where is it decreasing. So now I visualize. This is a parabola opening downwards, means it's going to be decreasing past the vertex in the positive x direction. This here tells me the location of the vertex is at positive 1. because this number in vertex form is a sign flipper. So I know that when x is greater than 1, it is increasing. Okay? And you can always throw it into Desmos and convince yourself. Like I look at, I don't know how many functions a day in Desmos. A lot. I'm sure there's people who look at more than I do, but not that many more. Okay, copy paste didn't work for that one. Negative 2x minus 1 squared. What was it? Minus 8? Negative 2x minus 1 squared plus 8. Okay. Plus 8. Not that that would make a difference. Okay. And I said that f of x would be decreasing when x is greater than 1. You see? See how f of x is decreasing. So it matches my mental visualization. I'm happy with that answer. Submit it. Yes. Hooray! Yeah. The function is decreasing for that. There you go. There you go. Okay, let's look at another one. Okay. We want to find the minimum value. Okay, if we want to find a maximum or minimum, you want vertex form. All right. So here the vertex is at 125. So the minimum value of this quadratic is minus 25. It's the y value of the vertex. It's right there. Submit that answer. Yay. Okay, let's do another. You find all the intervals where it's negative. We've done that one already. Let's find all the intervals. The x-intercept. F of x is negative. We've done that one. There's one more. The y-intercepts. Yeah, so find the y-intercept of this one. Well, again, let's look at our visualization. All quadratics have one and only one y-intercept because they're functions, so we would never have two, but they all have one. So there it is. And the form that gives us that, notice that this one's y-intercept is at 6, but I don't see the number 6 anywhere in the vertex form for that. I will see it in the standard form. Standard form will show me the y-intercept right there. Okay, so there's always one. There's one y-intercept, and the y-intercept, and it wants it in the form 0 in the x minus 10 in the y. Okay, it's just the number c in standard form. Super straightforward. There you are. So those are the types of problems that you're going to find inside there. So thank you very much for showing up for your learning. I have extended the deadline for the Delta Math so that you can use it all the way up until the test and keep practicing. And any questions, absolutely send me another email.